Hello students, in this video we are going to use prime factorization to help us find the square root of larger numbers. In this example, 1764, we will do the prime tree. Okay, so I know it's an even number, so it must be divisible by 2. So right away I know that's what's going to help me, right? So it's 8, 8, 2. You can check, is this correct? All right, so now one more time, it's also divisible by 2 again. So we divide that by 2, we have 441. Now 441, obviously it's not divisible by 2 because it's odd, it's not an even number. But let's check whether it's divisible by 3. Remember the rule of divisibility? We add the digits, 4 plus 4 plus 1, that's 9, which is divisible by 3. So clearly I know this is going to be divisible by 3. So let's see, that's 1, and then 4, and then 7. 147. Okay, one more time, we add 1 plus 4 plus 7, which is 12, which is also divisible by 3. So I'm going to one more time divide this by 3. So this will give us 40, that's 120, so 27, that's 9, so that's 49. And easily we know 49 is 7 times 7. So we have the prime factors of 1764, which is 2 times 2 times 3 times 3 times 7 times 7. So this will help us to find the square root of that large number. So you see that to find the square root of 1764 is actually the same thing as finding the square root of its prime factors, right? Multiple factors of the factorization, the prime factorization of the number. So I'm just going to write it one more time. So how does this help us? You see that those numbers, those prime factors come in pairs, right? So meaning if I actually use the commutative property of multiplication, I can rearrange the number and I have something like this. Think about it. Do you see that? So I actually have now one pair of numbers, 2 times 3 times 7, right, multiplied by itself. So we actually have 2 times 3 times 7 squared because it is multiplied by itself. So the square root of these numbers multiplied by itself obviously is just the number which we have in the beginning. So I hope this makes sense to you that now we have the square root of 1764 is basically 2 times 3 times 7. So meaning 2 times 3 is 6 times 7, that's 42. So I hope this makes sense to you. Another way to think about this is that I can write the prime factorization of 1764 as 2 squared times 3 squared times 7 squared, right? And then if I actually square root it, so I'm actually cancelling out all the squares, right? So we are square rooting square of 2, which is just 2. We are square rooting the square of 3, which is just 3. We are square rooting the square of 7, which is just 7. So in the end, again, you have the answer, which is 42. So you can check that yourself. Is that really true? 42 times 42 is 1764. So let's see. You can try this question yourself then. The square root of 30,625. So what do you think? Which prime number will you use first to actually split into factors of 3,625? look at the last digit. So does it give you an idea? Okay, so you try that yourself and then you check the answer in the calculator and see whether you are right. I will actually move on to a different question here. Now we are trying to find a cube root. So cube root of 1728. Actually, the nice thing is we have exactly the same strategy. So we will actually try to do a prime factorization of 1728. So again, we will split this into 2 times 8, and then we have 6 and then 4. So you can check whether this is correct. Okay. And then afterwards we split one more time, 2 times, so that's 4, 3 and 2. Okay, and then one more time we have 216. Okay, then afterwards we have again divide that by 2, we have 108. Okay, divide that by 2, we have 54. And then afterwards divide that by 2, that's 27. And then 27 is 3 times 9. And then 9 is 3 times 3. So, okay. So let's see what happens. We actually have now 1728 is basically 2 power 6. So 1, 2, 3, 4, 5, 6. And then times 3 power 3. Okay. Or if I would like to actually write it in the cube way, so then if I actually write this as 2 cube times 2 cube, do you see that? So 1, 2, 3, that's 2 cube. Okay, and here is another 2 cube, and the last part is actually 3 cube. Do you see that? Yeah, so we can actually write it this way, right? So the cube root then of 1728 must be equal to the cube root of these factors. So can we see now that when we do the cube root of 2 cube, result is 2. Cube root of 2 cube, again result is also 2. And then cube root of 3 cube, result is 3. So easily then the answer is going to be 2 times 2 times 3, which is 12. So let's see. You can use your calculator to check, is that really true? 12 times 12 times 12, when you cube it, is that really 1728? So then you can see it. You can see your answer. So that's how we use prime factorization to help us to find the square root and cube root of larger numbers. I hope this makes sense, and you can try and practice with some questions. Good luck!